Hi, this is Joe Bolen, and today we're going to look at how to debug a program that has errors in it. Having errors is normal, but learning how to debug is a skill that needs to be fostered and developed. And so today we're going to look at how to use the tools of Visual Studio's environment to help us debug a program that we detected has an error in it. So let's see how to do that. So let's go into Visual Studio. Okay, I have my very simple calculator up, and I'm going to show you that this one has an error in it, and I'm going to run it, and we'll discover where the error is. Okay, I have the calculator up and running. I'm going to type in 67 for the first number, and then I'm going to type in 34 for the second number, and then I'm going to hit the subtraction button, and we should come up with the number result of 33. But instead I come up with 2,278, which is definitely not the right answer for a subtraction of this type. So we know we have a problem in the event related to the subtraction button click event. So let's take a look at how we detect where the error is and to find out the logic that made this problem occur. So I'm going to close out the program, and I'm going to go to the code behind the program that we're running, and I'm going to go full screen. Here is the subtraction area where we have the subtraction button click event, and we see the variables being declared, and we see the process running through here. And I have also a subroutine that is going to display the output as I get my difference calculation. Now, what we do to find out how to determine the logic error is we come over here to the far left margin. We can also go up to the debug window, but it's easier to go to the far left margin to the gray area and click on the line number, the active line number, where we want to have a breakpoint to stop the program and allow us to start to look at what's going on. We can have more than one breakpoint, but this will start when I get into the subtraction button click event. And as we go through this, we'll learn how to use the debugging tools of Visual Studio. So I'm going to start running this program with the breakpoint set for line 56 so we can see what happens when I hit the subtraction. So I hit start, and I've got my calculator up and running. I'm going to once again enter in 67, and I'm going to put in 34 for the second one and hit my minus button. At this point we stop, and you'll see that the arrow to the side says this is the next statement that's going to execute. It hasn't executed yet, and we can begin to go through and watch what happens to our variables as we process. Also, notice down below I have what's called a locals window, and it shows me the variables that are in that particular what we call local scope of this breakpoint area that we're in at this point. So we see that we do have the first number and second number. We also have the difference, which is another variable that'll give us our results. We also see right now they have no values in them assigned to them, and we also see the form itself, ME, and the sender that brought it in, the button which has the minus button as the text. So let's go step through this. Now they're up at the top. You'll see that there are three buttons. The first one is step into F8. The second one over to the right from it is step over, which is shift F8, and the other one is step out, which is control shift F8. Most of the time we'll use the step into, but I'm going to show you where you would use the step over and the step out as we process through stepping through this program. So let's begin stepping through our program, and we'll go line by line and we can examine the variables that we have. So as we come down, we jump past the declarations because they aren't executable points, and we're ready to begin the tryparse of this. And right now it has no values in it. We can see, though, the text value is if I hold my cursor over the text property of first number text box, it shows up to me that I have the value of 67 in that text box, which is what I keyed in. I'm going to hit the next step into, and you'll go down the next line. At this point, we will actually see in our locals window that the first number has the value of 67 in it, which is what we keyed in the text box. So we see that the text box has parsed correctly into a double number to the first number variable, and we're ready to do the same thing for the next one. So we should see the second number change from 0 to its value. I'm going to hit the step into. And in fact, it did change to 34. And we're ready now to do the actual calculation. Right now, difference has no value. Let's do this, and we'll step into it one more time. Now, we should be getting for difference the value of 33. But we're going to see that we don't get it because of a logic error. And right now, the difference value has changed to 2,278. Well, obviously, this is not the right value, and we see that we've got a problem. And obviously, I can see above that I used multiplication instead of a subtraction operand for this particular calculation, and that's where my problem occurred. So what I would need to do is go in here and change this. So at this point, I can stop my debug. I can go in and change my code to make it a minus instead of a multiplication. And then I'm going to rerun this just to make certain that everything is correct. So I'm going to hit start again. And since I'm using the values 67 and 34, we'll do that again. I'll hit the minus button. Once again, we come in. I'm going to step into it, come down through the two tryparse sections where I've got now the values of 67 for my first number and 34 for the second number, and I'm ready to calculate the difference, and I should get 33. And in fact, I do get 33. Now let's see what the difference is. Now I can go to the step into on this one, and what will happen is this is a procedure that I'm going to be running, and I'm going to be passing to it the value of the difference variable into it as a valued reference to that location in memory. And we're going to see that the step into allows me then to go into that procedure. So I'm going to hit that. Yeah, I've already hit it again, and it's ready to execute the next value and process the output to the text property on that. So I can hit that, and then as I continue on step into, it'll leave the procedure, come back to the calling program part of it, and now it's ready to exit the sub there. And I'm going to hit it again, and it'll pop up with our window running again, ready to process this. So we can see that the step into allows us to come into a program, come down through our different parts of our program, and when we get to a situation where I have a procedure and I use the step into, I will go into that procedure. Now, one of the options is to step over, which is the second button on my icon area of the menu bar. And step over says basically, well, we're going to do the things that are in this location, but I'm not going to go into it and watch every variable. So here we see the step over being executed. And it jumped right from display result call to the end sub. I didn't go into the display result procedure. So that is what the step over button does. So if there's an area that we know is reliable and working correctly, we can use the step over button to process it. Also, since I know that I have no problems at this point, I can go ahead and just hit the continue button instead of hitting the step into button. So I'm going to hit the continue button and it'll come back. Now I'm going to do it again, and now we'll see another button in the debug process to use. I'm coming through. I'm going to use the step into. I'm going to come down through the Tryparse sections on that. And I'll continue to do the step into F8. And now I'm ready to execute this one. This time I'm going to do the step into, but we're going to see that I'm going to click on it. Now I'm right at the beginning of the display result subroutine. I can examine values here as well, and here we see that I passed into it the value of 33, which was my difference result on that. I'm getting ready to output that to my text box, or I should say my text property of the label. Now let's say I really do not want to step through a series of lines in this particular area because I know it's okay. Instead of continuing on with the step into, I can take the option to step out. Now, stepping out doesn't mean that I'm not executing those lines. It just means that I won't take time to look at each line. It will, in fact, go through and execute the rest of the lines through here and exit the subroutine and then come back. So we'll see that I can step out of that routine at this point without continuing on with every line of code. There, I pop back at this point to the calling part of the procedure of my subtraction button event, and we're back to where we came from. So the important thing to remember as we're looking at this is we can examine variables with the breakpoint. And what I did is I came over to the margin and clicked on it, and you'll see a big red button or a circle appear, and that'll be where we start the breakpoint. Now you want to set the breakpoint on an executable line of code. Setting it on the declaring area is not an executable. It's just a we're declaring and nothing's occurring. So we want to set it here or down at the double Tryparse line. We don't want to set it on a comment as well. We want it on an executable line, and we can come in and look at the locals to see the variables that are executing. Now, while I'm here, I also want to show you something different we can do with the locals window. As I continue on down and process this, you see that my local window shows first number is 67 and second number is 34. Well, we can actually, if we want to, change these values in the locals window instead of just seeing the current value it has. So in this case, let me change the value here to, let's say, we'll change 67 to 35. And I'm going to change it to 35. And now we'll see that it's been changed in my locals window. And so what I'm going to end up with is 35 minus 34. And we'll see that actually occur as we continue on. Right now, we see 33 for difference because that was from the last time we went through here. Let's go on down. And as we step through it, we'll see the result pop back up. We'll do it one more time. We'll come through. I'll step through it. We'll go through the Tryparse area. I'll change the value of 67 to 35. And this time we'll run the one, and we'll see that the value of difference is now 1. And we're going to output it. I'm going to go ahead and hit step over, and it'll pop back up with my particular line of code will pop, and we'll see that I get the value 1, the result, even though the text box values still show 67 and 34. What I've done is changed within the execution of the program first number to 35. So we could actually change variables as we run the program. Now let me stop the program. One of the things we can also do to get rid of the breakpoint is just double click on it to get rid of it. The other thing we can do is right click on it and keep the breakpoint but disable it. We might want to do this for purposes of later on testing it again, but right at the moment we don't need it to break. So we can keep the breakpoint in place to reactivate it. Or I can take it and delete the breakpoint totally off of the margin area, and at this point when I run it, it will not break. And it goes right into it. I can hit in the numbers 67 and 34, hit that minus sign, and it won't break because I've eliminated the breakpoint. Now the important thing to remember is as we go through with our breakpoint, we can step through and see each line of code that's executing. We can examine the variables by putting our cursor over the variable names, and it'll show up what the values are at the time with our cursor on the names. Also, our local window will show us the variables in this local scope of that particular area that we're in at the time. And we can use the step into, step over, and step out of buttons to control how we step through the program. And as we saw, by stepping through this one, we saw our logic error in this case was that I had miskeyed in an asterisk, which is multiplication, instead of a minus sign to do our subtraction. And my logic error popped out showing me that there was in fact a problem here. But I needed to know, of course, ahead of time with some trial data what my value should be. So I already knew that I was going to enter in 67 for my first number, I was going to enter in 34 for my second number, and that the calculation should give me 33 for my difference, which I realized it wasn't doing. So you need to also do what we call desk checking on that. So when you go through code, not only do you want to take advantage of using the breakpoint, setting a breakpoint and stepping through the code, examining the variables, looking at the locals window to see what the variables values are at the time, or even changing some of them during the run. But we also want to do what's called desk checking. And what we do is we basically have before us a script of values that we're going to enter into our application. And we also have what we consider to be the right results that we should be getting with the values that we enter in. And we'll have a number of values to enter in to test positives and negatives, fractions and whole numbers, to see if we're getting the correct values for all the different operations that we're running. You need to desk check your work. Don't assume just because you have coded everything and the thing has compiled that it's working correctly. You need to verify by desk checking, walking through, keying in your test values, and examining your test results against the real results you're getting with your program to make certain the logic is working correctly. If then you discover it is not working correctly, you go in and set your breakpoint and go through the program. Remember, we also have within it the step into, which will take us through each line after we set our breakpoint. And if we get to a procedure where we do not want to go into it, we can click the step over button to bypass going into the procedure and go to the next statement. Or we can go into the procedure with the step into button. And once we're in there, if we decide we want to exit early from our debug, the code will still execute within the procedure, but won't take time to look at each line of code being executed in that procedure by clicking our step out of button. It'll pop back up to our calling area where we started our debug and continue on through. So debug is a powerful tool to use. Back in the days gone by, all we had was the compiler checking our syntax that we had keyed in things correctly. If we had miskeyed or fat keyed in something into our source code, our program would be rejected and wouldn't run. If it did compile correctly, it would run, and then we'd have to look at the results. And sometimes the results wouldn't be right, and the only thing we could do is examine each line of code. And back in the days of the 1970s, all our code was on what was called Hollerith cards. Each line of code was a Hollerith card. So it took a lot to debug the problem on it. Today we have the nice tools that Visual Studio has within it with the debug. There are a lot of other great features of debugging that are available to you. Go out to MSDN to take a look at all the tools so you really become an expert in debugging. And until then, get your hands dirty in the code. Yeah, you're going to discover some errors, but you'll know the tools of how to debug. And that's the important skill you'll need to have as you become a programmer. So till the next time, take care.